What's up, you freaking geniuses? So in this video, I just want to give you an introduction into the properties of logarithms. And I'm also going to talk a little bit about expanding and condensing logarithmic expressions. So there's basically just three properties: the product property, the quotient property, and the power property. And these help us just kind of break down different types of logarithms, all right? So the product property just says if you have something like log base b of two numbers or two terms. Here we're calling them m and n. You can break those up into their own logarithms as log base b of m plus, right, plus log base b of n. Okay, so for example, if we had something like log base, let's say 5 of 4x. Now here we have two numbers, two terms, right, 4 and x. So we can, if we wanted to, split this up into a log base 5 of 4 plus log base 5 of x, okay? Or we could break it down like, let's say we had log base 3 of 21. If we wanted to break this down, or actually instead of 21, let's say 24. So there's different ways we can break down 24, right? We could break that down into, let's say 2 times 12, 6 times 4, 3 times 8. Let's use 3 times 8. So if you wanted to, you could break this down into log base 3 of 3 times 8, right? Now you can see we have two numbers or two terms, right? So then if you wanted to, we could expand this as a log base 3 of 3 plus a log base 3 of 8. Okay, and it's important to realize that we can actually go the other way. So if we had something like, let's say we started with this side. What if we had log base 3 of 3 plus log base 3 of 8? We could also go in that direction and say, okay, well, we have a log base 3 here, log base 3 here, so I'll just write it once here. And then here, since we're adding, we can just multiply these numbers together and combine them right here, okay? So that's called expanding and condensing a logarithmic expression. So here we start with a condensed form and then we kind of expand it out into its components, right? So that's called expanding a logarithm. But we can start with the components over here and then kind of glue them all back together and put them in the kind of original form, right? And that's called condensing a logarithm. All right, so that's the product property. Now the quotient property is very similar. So it just says if you have a log of two numbers, of basically a fraction, you can break them up the same way we kind of did here. The only difference really is instead of adding here, you would subtract, okay? So if we had something like log base 2 of, let's say, 3/7. So here we can break this fraction up as log base 2 of the top, which is 3, minus log base 2 of the bottom, which is 7, right? So that's one way we can break that down. Or if we had something like log base 5 of, let's say, 7 over x. Okay, again, we can split this fraction up as log base 5 of 7 minus log base 5 of x. Okay, and notice we can do the exact same thing. We can expand and condense a logarithmic expression in this manner also, right? Because we start with a condensed form right here, right? It's all together, but we can break it up into its bits. The only difference here being, again, we subtracted instead, right? But again, we can go in the other direction if we wanted to, right? If we started out with the parts, we could glue them back together into the condensed form, okay? So if you ever see a subtraction symbol between two logs like this, that means you can basically glue it back together as a fraction. Whereas opposed to, again, the product property, wherever there's a plus sign, you can basically glue this back together using multiplication, okay? Now, the last property I want to cover here is the power property. So this is the formula, but I think it'll probably be easier to just show you with an example. So if we had something like log base 5 of 7 squared. Okay, this exponent that we have right here, we can actually just toss it over here in front of the log. So we can say that this is equal to, it's the same thing as just 2 times log base 5 of 7. Okay, or if we had, again, just with a variable, so if we had something like log base 1/2 of x cubed. Okay, again, you can see we have an exponent right here, a 3, so we could just toss it to the front over here, so we can say that this is equal to 3 times log base 1/2 of x. Okay, so again, you can see that we basically start with a condensed form and then we expanded it to something else, right? So whenever you see a number out in front being multiplied by your logarithm, that means if you want to condense it back to its original form, all you have to do is turn this into the exponent, right? So if you wanted to go back that way instead, this number out here becomes the exponent on your term over here, right? Same thing up here. You can see that there's a number out in front of the log. So that means if you want to condense it, that would be an exponent in the condensed form. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.